Hey there, welcome back to Escalation. In this video, we are diving into one of the most and versatile data types in Python, that is dictionaries. Whether you're a beginner or looking to brush up on your skills, this video has got you covered. Let's get started. A dictionary is a collection of key value pairs. We'll look at it to understand where this data type is useful. In a random task, let us consider that we want multiple variables, like for example, if we are working on a data that includes car specifications, where we would go ahead and create multiple variables for model, fuel type, seating capacity, transmission type, etc., where each variable can have different values. In these scenarios, instead of creating multiple variables, we can create a dictionary as each of these values have a key or a name to it. To create a dictionary, we must separate all key value pairs with a comma and enclose entirely with curly brackets and give a name to it as a variable. Importantly, we can use a string, number, or sets as keys in a dictionary. In other words, the keys can be any immutable data type. However, values does not have any limitations as such. It can be of any data type. Values itself can be another dictionary, a list, etc. Unlike lists, which are indexed by a range of numbers, dictionaries are indexed by these keys. For example, if I want to retrieve only the model from this dictionary, I can index it using the variable along with the key, which is model in this case, within square brackets. You may wonder, how is this even working while we have keys being used as indexes? Well, for that, Python uses hash table data structure concept to store the data under this data type. Just to make the concept a little easier, we could imagine a table where these values are getting stored. Now, when we create a dictionary, Python creates a table with minimum number of empty rows by default. For this illustration, I will consider that the table length would be 10, and then each key in our dictionary is converted to a hash code, and that number is then divided by the total row count in the table to get a remainder. Considering that remainder as the index in our table is where the respective key value pairs are stored. Now, for example, let us say we convert the word model into a hash code. That hash code is divided by our table row count and get a remainder, which will always be lesser than our table length. Store this key value pair in that location. Similarly, we could convert another key into a hash code and then divide that by the row count to find the remainder and store that key value pair at that index of the table. Hash table includes multiple concepts like collision, where more than one key value pairs are stored at same index, initial sizing, hashing, load factor, and resizing, etc., which we will not worry about currently as it's entirely taken care by Python when we are working on dictionaries. For a better understanding, let me write a quick function to help you visualize the structure of a hash table as well. I will have the default table length as 10, convert each keys into a hash code for which I will use a built-in function. Each item's hash code is divided by the table length and take the remainder of it as the index for that key value pair. At this time, I would request you not to worry about creating functions as we will go through that separately in another video, but just to simulate the concept of hash table, I am writing this code. Now if I print our dictionary using this function, we will understand the concept clearly. If you notice, I am printing the hash code of each key, and you may also see the remainder here, and the same remainder is considered as the index to store respective key value pairs. The remainder on converting the text model to a hash code and then dividing that by 10 will give us 9, and that is the index where we see the key value pair of model getting stored. Similarly, fuel type will give us the remainder as 5, and 5 is the index of fuel type key value pair in our hash table, and it goes on likewise. We also notice in this example the concept of collision, where multiple key value pairs are stored at the same index. Normally, At this point, we would get confused between a hash table and memory locations. Well, don't get confused between a hash table and memory locations, as these values are stored in memory similarly to how our strings, lists, and other data types that we looked at in our previous videos. To avoid confusion, you could assume that these values in our hash table are pointing to a memory location. For example, as I mentioned earlier, we can include a list inside this dictionary, and if we go back and check the locations of those items, we see similar methods of storing each item at different locations. And it also applies to same values will still point to same memory location concept. For example, let us add another key value with the same value but a different key. Now if we check the locations of both these keys, we will see same memory locations of the values. The next question would be about mutability of dictionary data type. Of course, like lists, dictionaries are also mutable. That means it will avoid creating a new object when there is a change, but that is until the whole data is changed. For example, let me print the current location of this dictionary and update one of the values. Updating is simple in Python dictionaries, where we take the key as the index and assign a new value to it. Now when I check the location, it will be the same. However, if I change the object completely, keeping the variable names same, it will go ahead and create a new object, storing it in a different location. That covers the basic information required to start off with dictionaries in Python. Should you have any questions, doubts, feel free to post it in the comments section. Stay tuned for our upcoming videos on other data types in Python.